Okay, so we today we're going to be discussing kind of the basics of Python. Um, so we are going to be, and I have some topics that is going to explain. Um, and basically, this environment is called Jupyter. So it's a Jupyter Notebook. Basically, you can run, and it's running Python 3, so you can run commands in there. And here's the topics for today. And we'll be discussing. So yeah, we can just get into it. So arrays. There is basically, as compared to like Java or any other programming language, this. It's you can mix data types. So basically, we'll start with this. So we'll call this example. Example array equals. So there's a couple of data types you can think of. So you can do like 1, 2.5, hello, and 3. So let's say that's our array, right? And then you can run it. And then basically, if it computes, if this becomes a number, valid number, and there's no output, then you know that's a successful statement that you did. So I'm going to actually restart and run all. Just to make sure that all is there. So we have our example array now, and what we can do is we can do a print statement. So we can do print example array, and then run it, and then here. So you have basically you have an integer, a decimal value, so float, and then you have a string, and then you have an integer as well. The thing about this, like you can mix data types. So like commonly, like say for example, you in Java you had like a dictionary. So a dictionary would have a key and a value. So like, but then it would connect to so like a key would be say like like a student's name would be a key, and then a value could be their age or their height. But this one is like basically you can mix the data types, and there's some other things that you can do with say for example, if you had a numeric array, purely numeric is basically and we'll call this so we'll call it num array, and then yeah, so you can just come up with some values. So like say for example, so we can just do 1, 2, 3, 4, 5, for example, and then there are some things. So once you've created this array, you can determine some of the functions that you can call on it by using the dir keyword. So dir is a keyword, and actually it might be good to kind of explain what are keywords. So if you go to you can type in Python keywords, and this is pretty good just to see basically what are all the keywords in Python. And so basically later on we'll be using this one, the def, which is a function. And for this one, the one that I just used was dir. So it's not showing up on here, but dir is basically like directory. So like once you have the array, you can get all the methods access to it. So you can just call dir on num array and then run it, and then you have all of this access to all these methods, right? So for example, like we can do count, right? Count, and actually there's length too. So length, so we can call length on this num array. So can do this. I can call len, and these are all yeah, so we can call the length. So this would be a pretty easy one. And then because we know what we're expecting, so we're expecting 5. So there's 5 items in the num array. You can run it, and then you get 5. There is a contains method as well. So if we actually let's run this here, and basically so that we have access to all of those methods, and then we can put in here. So we can have length of num array, and then what other thing? So there is, you can call, I wanted to try out the contains method. So we know that we'll get something in here. So we can do num array, and I'm not sure if this is the correct syntax. So dot contains, and then we know that there is 1 through 5. So let's put in a 6 for now, and then hit run. Oh, so that's not the correct way. So if you don't know, if you don't know exactly the syntax in Python, you can just, basically the best way to do is just do a search, Google search, what is best syntax. So you can just do like array contain in Python, a simple search, and then check if an item exists in a list. So here's your list. There's count, start count, and length. There's length here, and should be another way actually. So let's see. If you wanted to do check if contain, oh, this is getting into strings. So actually this might be good in here. Tuple list. So basically there's a list, a sort, index, count. Let's see which one it is. Oh, let me move this down here. Okay. So basically, yeah, so there is a method in here. Get attribute length contains. So I think that might be actually within contain. I'm not exactly sure. So which one that would be? Contains. Do contains and The string contains. Yeah. But contains. Yeah, so see, actually, that might be the notation. Length. Oh, I see. I see. So this is actually saying, so like, here it is. So there's a blank, contains, and then another blank. So you need to call it this way. Uh, um, so there was length as well. So you can call it before or after is what it is. So let's see. Num array. Well, we just tried doing that. Name is not defined. Basically, size of. So if we let's say if we tried size of num array. So that is not, we're not getting dot size of. List object has no attribute. So this is a list. It's treating it as a list. So num array dot contains. So maybe if we try doing this way. No. Actually, yeah. So I guess we will kind of skip this part since not able to get what is expected. So there is, so basically what we did was, here's length, right? Length of the array. So we got what we expected. And now actually, if we wanted to access one of the indexes, so you can do num array at 0. So it's all 0 based, right? At 0, we have 1 as expected. And then at 4, we have 5. And we can actually do this. We could try, let's try doing 5. So there is, yeah, so index out of range. So try doing -1. So this is something kind of different from other languages. So like num array at this, you're at this index, you're -1, which shouldn't exist, right? But it's actually circular. So 0, so like you can think of this as, so basically we have, let me comment this out. So our index is 1, 2, 3, 4, 5. So this is what we have in our array. And then I'll put the index in here too. So 0, 1, 2, 3, and 4. So those, okay, so these are the values in the array, and these are the indexes. So if you just took this and kind of put it to the left, so like think of this as being repeated. So do 1, 2, 3, 4, and 5, right? And then we'll scoot this over this way, like that. So actually you have -1 here. And then -2, -3, -4, and then -5, right? So just kind of mapping those indexes. So that's why we got 5 as the answer to that. You may not expect that, but negative values do work as indexes, a valid index for the array. So like if we're expecting, now we know because of this, now we have a mapping of the array elements and the indexes. So if we did, like for example, if we did -3, and then we hit run again, we get our 3, right? And then -5 is, you can run it, and then it's 5, and then it's 1, right? So 1 index. So, and I don't believe there's any it doesn't stop. So basically, you can put in as long a big a value as you want, and you'll get, actually. So it did go back. So if we go to -6, maybe it won't. You'll get error. So -4 would be the last. -5. Yes, -5. -5 would be the last valid index. So like any of these are valid, -5 to 4. So if you think about it, it's basically 0 to 4 and -5 to -1. Those are 5 values. And this is also 5 values as well. So that's just something different. Different you could say about Python is that you can access something at the negative index. So basically, it could be used. I mean, it can be useful if you say you wanted to invert your data set. So this is like your data set, but you wanted to look at it in a different, like inverted, basically. You could use the negative indexes, and then -5, yeah. So try -5 is actually 1, yeah. So that's just, yeah, something a little bit different here. And we can do append. So if you wanted to append, can do num array dot append and then 6, right? And you can hit run. So then it was valid, right? And then you can just do print it out, and you can do that as well. If we try doing num array at, so basically the last index is 6, append will bring it to the last. It will add another index. So num array, and then basically you can add, so say like the last index now is at 5. So 0, 1, 2, 3, 4, 5. And say if you wanted to try it, let's see if this works. So like at 6, it's not defined yet, but we want to do this. So do run. You'll get an error here. So you have to use the append parameter. So the best, I mean, the way to do it would be call append again. So append and then 7, and then hit run, and then call num array. There we go. So that's how you add to the index, add to the array. And also, yeah, there's nothing saying that you can't add a string. So you can do num array dot append. If you wanted to append, you can do append hello. And then let's call it num array again. Yeah, so you can add the string if you wanted. There is basically, we can do so those are a little bit simple operations with the array, and so those are, yeah, the updating the arrays. Update image. So basically we last time and for just kind of recap is basically we showed this image here, and basically it's this is the format of the picture. So basically you have 1372 by 1372 by 3. By 3 would be like your pixels. So each pixel has a RGB value. And this PLT is matplotlib pyplot. So you can show the image that what you have. So like update image would be like, say, for example, we can do this. So let's set up a for loop. So our image name is just simply image, right? So let's say, for example, we wanted to do some manipulation on this image, right? So we'll update the image. Basically, we have, let's do something like, this is very bluish, right? A blue. Let's turn the blue pixels, so like relatively blue. So if we go into like a color mixer, color mixer. Yeah, here's, you can find various color mixers. There, actually, this might not be the best one. If we go into here, so RGB. Oh, this is color blender, so let's see. Actually, it should be RGB mixer. Here we go. So say, for example, we can set in this picture that we're looking at, we want to make all the blue ones like go to be white, relatively blue. So we can like set this, for example, we'll set this to 0, set this to 0, and then set this to 255. So relatively blue. This is actually darker. So and we can see this like blue and purplish. So we can bring in some red too. So anything like maybe something here, like somewhat, this is purplish, so 100, 0, 255. And like say that could be like your, if you wanted to look at something along those lines, 100, 0, and 255. So say, for example, if you have any color that looks like this, right? Then you're gonna, like, for example, and just for reference, all 255, 255, 255 is white. So what we want to do is basically go into here. Yeah, so if we want to, now we have some kind of value that we're checking against. So we want to like traverse through the array, basically this guy. We have basically we have a cube, right? So it's not it's a three-dimensional matrix, I guess. So now we can do like, if we want to define a for loop, it's pretty simple. So, and we have image dot shape that we called image dot shape. Look here, image dot shape. So basically we can get the rows, columns, and the pixel value. So we're going to be traversing the rows and columns. So we can say rows equals image dot shape at 0, and then columns equals image dot shape at 1. Now you have a reference to the rows and columns. So now we're going to do a for loop. So, and now actually we're going to check, basically we're going to be making a new, actually we'll make a copy first. So we'll make a copy. So image copy equals just image, right? And so that we have that original image as well, because we're going to be doing some manipulation here. So basically what our set points is, so like red the red value we want is going to be, if we look back on our mixer, is going to be 100. And then green value equals 0. And blue value is 255. So we'll just do this. So like, so say for example, we look at the particular pixel value. So as we're traversing through the three-dimensional matrix, and then basically we'll just do like a simple comparison. Like if we're looking for those particular colors where it's like anywhere from bluish to purplish, then we're gonna bring that into being a white pixel. So the way we do this is like, we have to define our for loop. So for in range of rows, and then for j in range columns, right? And then now we're at the pixel level once you have rows and columns. So basically we'll get pixel equals, basically we'll call it image copy at rows and columns. And then in order to get the red value, it's we can just do this. If basically it's just going to be one big if statement. So basically it's going to be like if pixel, actually we'll get the red, the particular red. So red of the pixel, red p, we'll call red p, is pixel at 0, and then green p equals pixel at 1, and then RGB, so blue p equals pixel at 2, right? And then we're going to do our if statement. So we're going to do our check here. So do if red p less than red value. Don't really need to do any check on the green. Green is just pass through. And so this is our and operator. And we're going to do blue underscore p. And actually, we don't even need to check. Or do we need to check? So yeah, let's put in a green value in here. So let's do this. Let's put in some check here. Let's actually change this to 200. So let's change this to 200, right? 200, there's 100 there, and some green value too. So this is where we're getting some of the lighter blue as well. So I like this one here, 150 as well. So anywhere, if we're anywhere less than that, actually now we have something to check against. So 150 as well. So we'll just do a less for all of them. We'll go back to our green. Yeah, green p less than green value, and blue p less than blue value, right? Then we'll say pixel. Well, actually, no, we'll do this. Image underscore copy rows and columns. We'll make this equal to all 255s. Basically, turn it white, right? So that's basically it. That's all that needs to be done. And basically, also, if you notice that semicolons are not required, semicolons also is used to suppress output. So if we did this num array and then added a semicolon, you run it, there's no output. If you get rid of the semicolon, it'll show the output. And actually it ran it again. So it ran it twice. You see what happened there. So each time I hit run, it ran this code again. So now we have, I hit it twice. So then it added another 2 hellos to it. And also it's important to do restart and run all. in case that, you know, you don't run into, if you run it again a couple of times and you didn't want to do it that, just to make sure that you do the right number of appends that you wanted. Anyways, this is the for loop. So you can just check the for loop if it's running good. Just hit a run, do a run. So basically, yeah, we're running into error here. And I wonder if we need to do add parentheses in here. Try that. Yeah, actually, green P. Yeah, so you can just check. I mean, if you're unsure about syntax, it's just a simple Google search. So and in Python, there's our operators here. And there's addition. Equal, greater than, less than, equal. So you can try and. So basically the letter, you can just type in and. Try and run. Oh yes, index 1372 is out of bounds for axis 0 with size 1372. So image copy. So 1372 pixel at 0. So oh yes, so we'd actually have to do rows and columns. So 1372 image copy. There, yeah, because you cannot access. Let's try -1 here. Add a -1. Oh. Actually, yes. Actually, this is the right way to do it. So this actually has to be 0. You need to add a 0 here. That is actually the red pixel. Actually, this is the same. This is not the. That is okay. If you did range and that one, it'll automatically. It won't go to that last index. So green P. So let's try it this way. Let's go into here. Add 1 there, and then blue. Yes, blue is going to be same thing here, but with a 2, right? Yep. And now if we run, oh, we're getting same message here. I wonder what is happening. So for I and J. Oh, I see what's happening. So basically we are not using rows and columns. So rows and columns is the incorrect. So we have to use the indexes, the I and J. So that was the mistake there. I and J, right? Because those are the actual things here. I and J. There we go. We hit run. Yeah. I and J. Yes, one more reference. I and J. So otherwise, it would just be. It's taking a while. So you know what we can do. There's an and. Yes, it did work. So this and, I'm not sure why. I would expect it to, you can try doing the scene, that if it worked like that. It did take a while though to complete. So yeah, so it has to be the keyword and. Let's just do a restart and run all. And basically now we have a copy of it. So we can, it's taking its time for it to update. Yeah, and let's see. Now what we can do is, oh, thank you for the comment. Yeah, so we have our image copy. So basically what we can do is plot what we did similarly like last time. So we just do plot IMShow of our new image, right? So let's see this. Let's see how our image will look. So plot.IMShow. And then this is basically image copy, right? And then hit run. Yeah, so this is basically the updated image. So basically now you can see where the white is, right? So it took those images. So basically what we did was we took those colors in a particular, now you can, you can change those if you wanted to do greater than. So like say, for example, we did greater than, right? And yeah, so if we do wanted to do side by side, let's see how would we do side by side. So we can do this. We can just call, let me put a cell, it's up there. So let me bring the cell up above and call plot.IMShow, call image, right? And then you can just see side by side. Oh, actually it did change. So this image copy, it actually did change the image, right? So in order to get back that image, this copy is actually a reference to the same thing. So if you wanted to make like a separate copy, so you can just say here, image copy in CV2, right? We wanted to clone, how to clone to return a copy. So image.copy. Yeah, so basically, yeah, see what happened was it did the changes for both, right? So the way we do that is we need to know with the same data as the original image. So the way you could do that is you can, since we did this copy here, let's do this. The harder, I mean, the kind of more impractical way of doing it is just defining an array. So like an empty array. So like can do numpy.0. So like if you look at numpy zeros, right? And then you can give it a shape, right? Shape numpy dot zeros. So we know what the shape is. So like say we do make an image copy, right? Image copy equals numpy dot zeros. And then we have our rows or columns and 3, right? So now actually there's a if, right? And then we can put in an else here too. Image copy I and j image, right? Image at I and j. So then we'll add an else in here as well. So image copy. And this actually, this is good. Because this won't, it's not going to affect the original image. So then if we did hit and restart and run also, then we would expect two different images. So there's the original image, and so there's our original image. Image copy. Oh, data type not understood. So this is numpy. Oh yes, I need to add another. So I need to add another parentheses in here twice. So we do kernel and then restart and run all. And then this should work as expected. I'll give it some time. Here. Yeah. Okay. Oh, I see. So this got clipped. Clipping input. So we did have input. So we'll do a divide by 255 as well. They did get, so let's do this. Divide by 255. And then, yeah. Actually, this might go into the data type, because the data type, we'll just see here. Restart and run all. It did get clipped. So, and we'll see here what the data type is, because this we're using NumPy. When we do our separate copy, we want a separate copy so it doesn't affect the original image, right? So yeah, we're not getting the right image. We're not getting the updated image. So actually, I think the best way is probably just create a separate instance of it. So we'll just do this way. Instead of doing this, it's we'll just call the image, like create another image out of it. So do the IAM read again. So that's probably better. If we just do that, cv2.IAM read. So we have 2 instances of it. So this way then we know that it's separate, completely separate. And further, yeah, the issue that was happening is next thing I think we'll see like the data type. Oh, I should leave. I should have left those pixels. Should change those back to what they should be. Otherwise, we'll get all black. Yeah. So we'll do this. 255. All black because basically it's very close to the all 0 value. So like if all the pixels are 0, it'll turn black. So I do have another comment here. Yeah, so thank you for the comments. Greatly appreciate it. And yeah, we'll do run all. And let's see. Now what we did to kind of recap is we called imread again on the CV2 package. So basically we have we're calling an image copy and an image. So those are two different variables, completely different, so that we can see the difference side by side. Yeah. So there is, now you can see definitely like what changes we made. Yeah, so that's that was the topic that I planned for, which was to update the image. Next is, so I'm going to actually, you can just comment this whole thing out. So this one's actually just taking a lot of time. So let me comment out this guy. I can comment out, and again, the comment is a hashtag, right? So, and multi-line comment. You can just, yeah, you can just see multi-line comment. In Python, multi-line comment, Python. Yeah, so it doesn't support multi-line comment. Yeah, so the only way is with the hashtags. So what we can do is, I think the for loop is taking a lot of the, that's why it's taking so long. So we'll just comment all this out, right? Now if we hit restart run all, it should not take long. Okay. So next is Tuples. So Tuple, again, this website is very good, W3 Schools. You can just type in Tuple in Python. So Tuple is basically, you can think of it as in parentheses. So like say we'll call it tuple test. And actually tuple is a keyword. Tuple test equals, and then 2 and 2. So that it ran, right? So this here, it ran. So actually it's just a different format, really, more than anything from what we were discussing earlier, which is an array. Tuple test, and then tuple test add 0. It's similar, you know, you can get, and then you get your index there. This, I mean, for example, like it would be good. So say you had XY coordinates, right? Then you could say your X value is at 0, and then your Y value is at index 1. So that's pretty much tuple. Is just another, and also if you're unsure about something, you know, definitely W3 Schools is a good one. But there's also a bunch of, you know, things that you can look online for, just to understand something. I mean, what exactly is a tuple? So yeah, that was one example of it. And next is matrix operations. So matrix operations, let's say, okay, so matrix, let's define a matrix using NumPy. So we can do, let's do, for example, let's try doing NumPy.org. So let's try, let's say, for example, like we do a 3x3 matrix and then like do a transpose on it. So let's do a transpose and like addition of two matrices. So basically we're going to define our matrix A and the matrix B, right? And it doesn't matter really what we put in here. We'll put in 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we can just bring this in. We can copy this in. And then we can just continue. We can just continue on. It doesn't have to really be. I think more we're concerned about the concept really, rather than what numbers. 15, 16, 17, 18. And see. Oh, a comment is brilliant. Yes. Thank you. And yeah, let's see. So yeah, we can print A and B out. So you can just do A comma B. Do run. Yeah, so basically, yeah, we have the matrices. Now what we're going to do is we can call transpose. So A dot transpose. So let's see, here's A. Here's our original matrix. And then we can call transpose. So A dot capital T. That gives you the transpose. So basically the rows become the columns. And that's basically the transpose. Pretty simple. You know, like, and so say like, for example, we wanted to do the addition, right? So we wanted to do addition. Can do A plus B, right? A plus B, and then yeah. So we have basically adding both of the matrices together. That's pretty much it. I mean, you can do plus, minus, and if we wanted to look more into what you can do with NumPy, NumPy can just do a search, NumPy matrix operations, really. And this actually, this is matrix, right? So like this is the actual keyword. What we did here was basically we used array of arrays, which is basically the same thing as matrix. But there is actually, you can do matrix, right? Which is a different form. And there's all of these methods as well. So basically, yeah, there's all of this transpose, and so basically it would be the same exact thing. So, and this is a little bit different on how it's written. A NumPy matrix, yep. So this way is a little bit different, yeah. So say we wanted to use the matrix one. We'll call it a map equals NumPy matrix. How we put in here is, so basically the way they have it is with a space. So they have spaces 2, 3, and then looks like semicolon. Yeah, they have a semicolon in there. So, and then you have 4. And then I guess what we can do is we'll call transpose on this and see if it's we get the same same output, right? And then let's see, a mat.t, right? And then we'll hit run. Yeah, and then the only difference really is that you have the matrix instead of the array as expected. So that's a simple matrices. I mean, if you are at all familiar with MATLAB and linear algebra, all of the linear algebra topics can be done relatively quickly with Python. What I wanted to do was this solving the equation. So you had ax equals b. a matrix multiplied by a vector gives you a vector, and you want it to solve for x, right? Given that you have the b vector. Say, okay, so then we have our a, right? We have a, like, let's say like our b, b vector, we'll call it b vec equals numpy dot array, and then we'll call it, actually, we'll do this. We'll do 6, 6, right? 15. And you'll realize why I'm doing these values. They're relatively, you will figure out why I'm using these. So basically 6, 15, 14, if we want to print it out, be back, run it. We have an array here. So we can look at A. We have our A that we defined up here, and we have our vector here. So we want to know which vector, if we multiply by our original A matrix, do we get the B vector, basically. So in order to solve AX equals B, numpy, you can just do this, numpy.linearalgebra.solve, right? So we already defined our numpy, so it's like numpy, which is numpy.linalgebra, right? Linalgebra.solve. Then we put in our A, which is A, right? Just A, and then we put in our B vector, right? And say we wanted to print that. So this is our X, actually. This is X, and then we wanted to print out X. Yeah, so actually was not exactly expecting that, but yeah, so actually, what is the order? A and B, right? AX equals B, right? Coefficient matrix. AX equals B. Yeah, I think this might be it. Yeah, because we are looking, we are actually looking for, might not be as actually, so it's like 1 multiplied, so basically this is saying 1 multiplied by negative 0.6, and then 2 multiplied by 4.2, right? And then 3 multiplied by negative 0.6 will get you 6, right? So you look at negative 0.6 plus 8.4 minus, we do minus 1.8, right? Is that the right thing, or may not be 1? Yeah, I'm actually, because we want it to be equal to 6. 8.4 minus 1.8. But anyways, I mean, without getting into details, really, this is how you would solve your AX equals B equation. Although I was expecting all ones, but this would be a little bit different because let's see, for example, if we wanted to do very simple, like very, very simple, I can do this 1, which is the identity matrix. So identity matrix is, can just do 0, 1, 0. We'll just change this to make it even simpler. we have our identity matrix. So basically, if you do identity matrix times the vector, you will get the same vector back. So in this case, you know, our b vector is 6, 15, 24. So our x should be 6, 15, 24. So we can check making that change a to the identity matrix. We can do a simple check that, hey, we're getting the right answer using the solver. So do restart and run all. Yeah, so basically it's a simple check. We're getting what we put in as our b vector because it's a simple check, you know. And yeah, so that's some matrix operations. Okay, now we're gonna look into this function problems, and actually we did cover a little bit on keywords in Python. Function problem. So very simple function. The cool thing about if you do an array, so like let's do an array again. So like array test2. We'll call it array test again. It doesn't really matter what we define it as. Array test again. Let's just define. Okay, so 1, 2, 3, 4, 5, 6, 1 through 6. Okay. There's a cool thing you can do is you can call sum. Just call sum. It's a keyword. Array test again, right? And we'll call run. So 21 is the answer, right? So let's say like we wanted to do a function, right? We want to define a function that will give you the mean of an array. So I know there's probably a way, I mean, you can find the mean, like there's probably a simpler way or like a keyword, but this would kind of give you understanding of what exactly goes into like all of these sum, like say for the sum, right? What's behind, like what's underneath when you call sum, like what is, what's actually happening, you know, like at the lower level, right? And we'll do this, and also it's kind of double dipping, you know, like we understand functions a little bit more. So functions require a keyword, so def, which is the keyword. So basically we're going to be using two of the already defined. We're going to be using sum. In order to find mean, you just need the sum and you need the length, right? So can do this. So define, call mean array, right? And then what we need is just the array, right? You can call it A. Doesn't really matter what you put in there. It's very like, you need to define what data type it's expecting. So what we need to do is basically just return. Very simple, very simple. Like you can do this in one line, actually. You could just do return sum of A and divided by length of A. That's it. And then if we want to test it out, you can just go through print. So what are we expecting actually? In order to, let's actually make this somewhat like nice, you know, something that will, so we have 6 values here. And we're expecting like a whole number, right? So like say, for example, like say that we come up with a whole number, no decimal required, right? So we're at 21 right now with 6 values. Let's bump it up somehow to get 24. So then we know that the average will be 4. So let's change this to 9. If we change that to 9, then you know that the average is 4. So let's, and then that's a kind of easy check. So you can do print, and since it's returning it, you can also like set it into a variable beforehand. So you can just say, we'll call it mean test, right? Is going to be equal to mean array, right? Array, and then array, the one that we have in here is array test again, right? And then you can just print out this guy. Actually, you don't even need to do a print statement. You can just do this. If you have a single thing, you can just do this main test, right? Hit run. Oh, we're getting 3.5. Why are we getting 3.5? Because we ran this code before this code, right? So actually we need to run this one first. Then we can run this one, then we'll give it a 4. Operation is important too, you know, like once say like you added in this code, you have to make sure that the variable you're referencing is in a different block of code. You have to make sure that like it's just like kind of order of operations in math, you know. You have to make sure that this executes first, because we were expecting this 4, right? But it became 3.5 since we had not updated our array test again variable. So very, very, very simple function. And I think another thing about like just like computer science in general, or just learning a new programming language, I think less is more. I think every line has meaning, and like if your line, like if whatever function you're creating is becoming very lengthy, there's always like some way to kind of slim it down, you know. And that's like the best way really, is to just make it as concise as possible. Like this is only one line of code as your function. And basically, if you think about it, it's like, it's kind of like layers, right? You have a layer, right? Length is something that's within, you have something, length is a function itself, and so is sum, right? So you took the two functions and you made another function out of it. So it's just like building on top, you know. That's basically, if you think about like for other things as well, it's just like layers and layers and layers into something really more complex. But like at the kind of lower level, it's just all these simple functions really. Okay, so that was a basic function, you know, determine mean of the numeric array. Okay, so we're going to do graphing values using matplotlib. So basically we use matplotlib to plot this image that we had. What we want to do now is, like, say we wanted to plot like a graph. Matplotlib, you can just search matplotlib graph. Sample points, right? We want to point, say we had this, a line plot, right? You wanted to plot X and Y, right? And plt.plot. So we have, we already have this reference matplotlib.pyplot as plt, right? So say we had, this very, like, we can do a line, right? Just a simple line. We can do our X variable. We can do like X equals like 1, 2, 3, 4, 5, 6. Actually, let's do like a parabola, like for example, x squared. And let's do this, -5 to 5. Actually, this is, if we do this, if we run this, actually, I don't think this would work. Yeah, I don't think this would work. Yeah, let's just do this. -4. Actually, let's try this, -5 to 5. Yes, this will work. Now you can run this. This is easier than, you have a range, right? X at 0. But this is actually an array, if you think about it. It's coming up as a range, right? X at 0, it came up as -5. And then X, then you have basically 10 values. Actually 11 values. So like if you do the X at 10, yeah, so actually it would be X at 9. We do have 10 values. X at 9 is 4. So let's do 6, -5 to -6. And then what we can do is, we'll do this, y equals x squared. Yeah, so x dot, I think it might be dot. Actually, not dot. Or we can just do this. you can just do a simple for loop. Range of x. We'll just make an empty array first here. Then we can do y dot append x squared, right? And then we'll print y. So we have y. Oh, we forgot a colon here. Range cannot be interpreted as, oh, yes, it needs to be I here. Actually, x at I. That's what it is. For I in range. Actually, we'll just do this -5 to 6 because that's a little bit different, yeah. Oh, actually. Oh, this needs to be comma. There we go. Okay. So now what we have is actually this should be actually this should be range actually from 0 to 9, 0 to 9, right? This makes sense. This is actually what it is. 0 through 9. Actually, we have 10 values. Yes. So this is what we have here. And basically what we're trying to do is y equals x squared. So you can just do here plt dot plot, go x and y, hit run. Oh, right. And they must have the same dimensions, right? Dimensions is very important. If you mess up the dimensions, it won't plot. So let's change this. Actually, let's change that. Yeah. So important to have the same variable, and I'm not sure why. Yeah, actually, it's -5 to 4. That's why it's happening. So let's do this. Let's go to 6 here, and let's change this to 11, so it seems more symmetric. There we go. Yeah. So very simple. I mean, you can do like a plot. Obviously, we don't have that many points here, so then you can see that here. If you zoom in a little bit, you can see that there's actually, you can see the actual lines. But if you did some smoothing, you know, you could do some smoothing. -5 and then -5 to -6 actually. Let's see. There is a step size. Let's see if there's a step size. There's actually, we run this, you know, we have our plot, but if we wanted to smooth it out and you wanted to know that how could you smooth it out? Range in Python, and we need the step, right? That's what it is. So there's a start, right? See, basically, yeah. So 3 parameters. So basically we want 3 parameters, right? We want to do 0.1, right? And then let's see if we can do that as well. Oh, it needs to be steps, steps of a whole integer, right? So yeah, I think for now we'll just leave it as is. But there is, I mean, there is ways where you can smooth it out. Basically, if you have more data, definitely it'll appear smoother. Yeah, so that's like a simple plot. Matplotlib. Matplotlib is PLT, right? And then is the plot function. Yeah. So next in the topic was, yeah, so rotating the triangle of stars. So how could we, if we looked here, so basically we have these stars here, and what we want to do is, instead of having it appear this way, which is a triangle, we want to basically, what we want to do is like rotate the triangle. We want it to rotate 90 degrees, yeah, 90 degrees counterclockwise. So then this part is actually like to the top, right? So this is like more like finding the equations, like math equations, in order to make this happen. So basically you're going to print out like a bunch of spaces, right, before hitting the, um, before going and hitting the star. So basically, if you notice, this is more like noticing the patterns first. So I think better like we just do cell here, so we don't keep going back and forth. So if you notice here, so basically the pattern is, so like say like let's try with smaller one. Let's try with 3. We have 3. The first row will have 1. The second row will have, actually let's try with 5. Then we can see more of the pattern, what's happening. The first row will have 1. The second row will have 3. Third row will have 5, 5, 7, 9. So you can see the pattern is, and compared with the index, so like basically we have 1, 2, 3, 4, and 5. So basically it's doing, see here, like, and then this one is actually 7. So 1, 2, 3, 4, 5, 6, 7, right? And 1, it's adding 2 for each row. It's adding another 2 to the next row, basically. The basic pattern is going to be 2 multiplied by your row minus 1 is this is basically the equation here. So let's comment this out. It's useful stuff. Useful for what we want to accomplish. So basically, and how many, like how many spaces you have. So like if you look at the first row will have 1 star, but 1, 2, 3, 4, 4 of the spaces. So basically you can have 4 spaces, and then 1, and then basically we don't need to do anything afterwards. The spaces afterwards don't really matter. And then so can do, I think what we can do is, let's try this. So for I, so basically we can have in range of base triangle, right? We're going to and then if we look at the spaces, the white spaces, it's going to be 4, 3, 3, 2, 1, 0. So those are the white spaces, right? So this is, I think we should move this one up to here, right? So we have our index, the row number, right? Number of stars and number of blank spaces, right? So starting off is going to be your blank spaces. So for I in range, so basically this will get you your rows. What we're going to do is, actually, this will get you the next line, to the next line. And we don't want to do the end until, this should be the end. So we're going to just keep doing print, right? Print. And if we just keep doing prints, actually that'll take you to the next line. right? So we want to know how many prints should do. So like we'll just do like print on same line, Python. Right, what we want to do is print. Yeah, so print we want to do if we do an empty thing, so like print, yeah, we can just try something here. Just try this. Just try like do some simple testing. Print empty space and then print a star, right? Wrong, but did print the space on there, so I think we're gonna have to have end equals like that. Yeah, so then it'll add that. So basically, just add some spaces here, and that'll shift it, right? So if we want to do print this many spaces and then number of stars, right? So we're gonna have one for loop to do our spaces, and then the other for loop to do our stars, basically. So within here, we're gonna have something. So anyways, if we're gonna do zero base, actually, I should have kept that there, just for reference, really. You can see 0, 1, 2, 3, 4, right? And actually, if you think about it, it can be like 2 times row, and then you can just do +1, right? So those are the number of stars that we're going to print out, and the number of spaces is actually going to be a little bit different. It's going to be so it's going to be, if you find the pattern, right? So 0 gives you 4, right? And then 1 gives you 3, 2 gives you 2. So it's basically inverting it. So it's going to be, this is the equation for the stars. And then this is for, if you look at 0, 1, 2, 3, 4, and then 4, 3, 2, 1, 0, it's going to be -1 multiplied by the row, right? And then +4. So this is going to be the empty spaces, right? Right. And so basically we just create the string. We can create a string that would have that what we wanted. So basically we're going to do our empty spaces first for j in how many. So basically the empty spaces is 1 times the row +4. Basically we want to just create that like empty string, basically. If there was an easy way to do that, yeah, let's see. We'll do this. We'll just call this our empty string. Empty, right? And then let's see, for j in range 4, 3, 2, 1. So I -1 multiplied by the row right? Plus 4, right? Actually, this should be I, right? And then we'll do x dot append. We'll append a space, right? Right, and then we'll do our print, right? So we'll print x and then end equals this much, right? And then we'll do 4k in range, and then this is going to be 2 multiplied by I, right? And plus 1, right? And then we'll just do our print statements, print the star. And then at the end, we can just do an empty print. So hopefully this, unless I messed up with the append, and there's some other way to do it. Invalid syntax. Oh, must have added, I need to add another. Oh, maybe not. No, there we go. I think I added in another. Yeah, so there's no attribute append. That's the thing. So let's see how to add to string in Python. So we can do concatenate. There's a concatenate option. Or you can do plus equal. Plus equal is probably better. Now, append is not the right one. I do x plus equals empty space. All right. Whoa. So yeah, it looks like not the correct of what we wanted, right? So we have our base triangle. Oh, base triangle was 5, right? Yeah, 5. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 4. Actually, then we do a print. Let's see if we get rid of this. Let's see what happens. So we're not getting what we wanted, right? But we are getting some spaces. That's the thing. Let's see if there's any other way we can do so. We have our x. That seems okay. If we just did our x, let's see what happens. How many of those do we get? Okay. Okay. And we'll call it print, right? So I think we have, let's try this. We could do print I. Okay, so that at least that part is working, right? At least we know that is, we're getting that many spaces, right? We need to know why we're not getting print statement. Yeah, so at least we know that this is okay. We need to see why. If we call print, where exactly do we need to call print? Yeah, because this is basically, all we really need to do is just change the index with the however many stars, right? So let's see if we do this. Let's just see, like, I think a good way if you ever get stuck is like you just look at it step by step, break it down. See, you know, like commenting out is very like, it's very helpful. Just comment out sections that you don't want to test, you know, you want to test it on, bring it on like next, right? So print, I think this is what, yeah. Yeah, so this is where it's all getting a little bit messed up. Okay, got you. Okay. Comment. I think what we can do is we can add another space. You know, like we can add some more space to it. Can add 4. Actually, no, there's 2 right there. We wanted to add some more spaces. Let's see. Whoa. Actually, that's the thing. I think we need to add some more spacing, might be the thing. Let's try our print I again. Let's get rid of this. 0, 1, 2, 3, 4. Yeah, that's I guess can. I mean, oh, you know what's happening actually? I think with the print star, it's oh, print I, see the print I, it brings on another line. That's what's the problem, I think. So let's try this. There we go. That's basically, that's what it is. Actually, with the spacing is a little bit different. The spacing is a little bit, it's also dependent on the spacing because there's a star and a space. Is if you can see the end, because that's where we're adding. We're adding, actually this is adding a space in here. So if we do this, right? There we go. Now it's like, now it's a little bit better because see, and up here too, we were adding this space as well to the end of it, but making sure that's on the same line. So yeah, that's basically how you rotate this guy. How would you add, because basically it's adding another space. I think if you wanted to take this exact thing and do, like actually do the rotation as we're talking about, you would need to know the pattern. Like, so how many spaces are there actually? Basically there's, for each, so there's 1, 2, 3, 4, 5, 6, 7, 8, right? So it's actually doubled, right? So 1, 2, 3, 4, 5, 6. So we're gonna have to double this guy. We want to do the exact thing too. Yeah. So it's actually -1. If we do a -1, so it's actually a little bit different. So it's actually multiplied by -2, right? Multiplied by -2. So take your -2 times I, and then do 8, right? 8, and then you can add in the space as well, because that, and then that will match. This should match, right? A rotation. Yeah. So this is basically the rotation of what we had accomplished earlier. So, and obviously you can, definitely, the only really thing you need to do to put this into a function is this base triangle. And in order to really, this, you would need to, you would need to definitely figure out what is the generic, what is the pattern in order to get this output. So I think that's pretty much all the topics that I wanted to discuss. And hopefully it made sense, or any comments, leave any comments. Anything I could have explained a little bit better. And yeah, I think I will stop recording now. Thank you.